Hello friends, good morning. Today we are starting a new lecture, rather new chapter naming inverter. So till now we have seen three different chapters. First is introduction, then other semiconductor devices and control rectifier. Now we have seen that in control rectifier we have seen single phase, half wave, full wave, three phase, half wave, full wave, rectifier. What is rectifier? If you remember, rectifier which converts AC into DC. And now we are going to learn inverter. So what is an inverter? Inverter, I can say a circuit that converts DC power into AC power at desired output voltage and frequency is called an inverter. Okay, so we start. Okay, so just now I said the definition of inverter. I will repeat once again. A circuit that convert DC power into AC power. That is the basic definitions. But I can add it as a when it converts DC into AC, it gives us a desired output voltage and frequency. Is called as an inverter. So what are the applications of inverter? In your house, you might have seen there is an inverter, or you might have installed inverter. So whenever electricity gone, you will be using the supply from the inverter. So what are its other uses? Industrial applications. So inverters are used. Okay. Typical applications are adjustable speed AC drives, then induction heating, standby aircraft power supplies, UPS for computers, HVDC transmission lines, etc. These are some major use. Actually, there are many more uses, but these are some major use of a inverter. Okay. Now, inverter can be broadly classified into two types. One is a voltage source inverter, and one is a current source inverter. Okay, a voltage source inverter is also called as a voltage fade inverter. Okay, it is one in which the DC source has small or almost negligible internal impedance. Are you getting? A voltage source inverter has very small or negligible internal impedance. Or in other words, I can say that voltage source inverter has steep DC voltage, means constant DC voltage source at its input terminals. Similarly, what is current source inverter? A current source inverter or current fade inverter is fed with adjustable current from a DC source of high internal impedance. Okay, so it has a steep AC current source. Here, VSI it has a steep voltage source. CSI it has a steep or constant current source. Okay, so these are some basic types. Okay, now VSI in general in voltage source inverters which are using thyristors, some type of force commutations is usually required. Okay, if I am using a thyristors, then obviously to commute a thyristor is not gate commutated device. It requires gate just to turn it on, but to turn it off, we require some external circuitries. Okay, so we may be using BJT, MOSFET, IGBT, SIT. Now this can be turned off by the control of their base current. Okay, so switching of the devices with the help of their gate or base current is called as a self commutation. So self-commutated inverters using GTO and transistor do not require additional commutation circuitry. Are you getting? So GTOs or self-commutated device does not require additional circuitry, but if it is a thyristor, it will require additional circuitry. Now, from viewpoint of a connections of semiconductor devices, okay, the fashion by which we are using the semiconductor devices, inverter broadly classified as a bridge inverter, series inverter, and parallel inverters. We will not go deep in it. We mostly dealing with the bridge inverters only. Okay. Now next point is a performance parameters. Okay, performance parameters. Now inverter generate AC output, right? If you have ever observed, whenever a inverter is on in your house, we can see a humming noise from your fan. Okay, so why we are getting this humming noise? Or for every particular load, we can see its working is not as smooth as when it is on a your general MSAB supply or that supply. Okay, this is because the output voltage waveform generated by inverter is not pure sinusoidal. Okay, it can be a square wave, it can be a quasi square wave, or low distorted sine wave. Okay, now these waveforms contain some harmonics, some distortions. Now these harmonics is ultimately affecting our load or its performance or life of the device. Okay, now how to measure this harmonics? So there are different parameters. Okay, so we'll start it with the harmonic factor, which is called as HFN. Okay, harmonic factor of nth harmonic. Now how it is defined? It is defined as a ratio of RMS value of nth harmonic to the RMS value of the fundamental. Okay, so if there is a third harmonic present, for a simplicity consider, if there is a third harmonic present, then the ratio of RMS value of third harmonic to the RMS value of the fundamental. Okay, Vn by V1, where Vn is a RMS n for a nth harmonic. So value of voltage of nth harmonic divided by value of voltage of first harmonic. Okay, so this is called as a harmonic factor. Okay, HFN. Now next and very important point is the total harmonic distortion. You might have listened many times in electrical engineering about a THD, total harmonic distortion. So what is total harmonic distortion? A total harmonic distortion is the ratio of RMS value of all harmonics to the RMS value of fundamental component. So see, where Vn is a RMS value of nth harmonic, where n can be run from 2, 3, because 1 is a fundamental harmonic, no? Fundamental frequency, that is 50. So n will run from 2, 3 up to infinity. Okay, so any harmonic other than 1 is a unwanted harmonic. So we can see that Vn square when n runs from 2 to infinity. So it is the ratio of RMS values of all harmonics, okay, to the fundamental harmonic. It's called as a THD. Okay, it is a very important point. Total harmonic distortion generally indicates the distortion in the waveform. Okay, so how much waveform is distorted? If THD is having value say 10%, so I can say that your output waveform is 10% distorted from your actual or expected waveform. Okay, okay. Now the distortion factor. Sorry, distortion. This is another factor. Actually, I have not given proper reading. The distortion factor. Now, what is distortion factor? Or it is also called as a DF. Now, distortion factor. Here we can see the formula. Okay, the distortion factor, it is the measure of harmonic distortion that remains in the particular waveform after filtering. Okay, so you might have filtered the waveform, but even after filtering, some particular harmonics remains in the waveform, which is called as the distortion factor. Okay, so we can see the formula that Vn upon n square. So Vn is a nth harmonic. So suppose second harmonic divided by second square whole square. This is the coming back to the point. Sorry for interruption. Okay, so distortion factor is the measure of harmonic distortion that remains in a particular waveform after filtering. Okay, so you are having this formula, distortion factor. Now next point is the lowest order harmonic. Lowest order harmonic is a harmonic component which has nearest frequency to the fundamental and its amplitude is within 3% of the fundamental component. Okay, so this is called as the lowest LOH, lowest order harmonic. So a harmonic component which has nearest frequency to the fundamental frequency is 50. So it is having nearest frequency to the fundamental and its amplitude, okay, its height, its amplitude is within 3% of the fundamental component. It's called as the lowest order harmonics. Okay, this is very important. So you might get up numerical to ask THD, sorry, THD, and you can utilize the formula and you can get it. Okay, we'll see the numericals also. Now we'll start with the actual chapter. First point is a single phase half bridge inverter. As I said, there is a different types of inverters: bridge inverter, series inverter, parallel inverter, and we are mostly dealing with the bridge inverter. So in bridge inverter also there are two types, that is single phase half bridge inverter and single phase full bridge inverter. Okay, so here single phase half bridge inverter have been shown. Okay. Now single phase half bridge inverter can be with a resistive load, can be with a inductive load. Okay. So here for this first case, I will consider load is a resistive. Okay, purely resistive load is there. So in that case, even though you have not shown this diode, then okay, listen carefully. If load is resistive, diode is of not use. Okay, so you can